Now we are looking at the miscellaneous examples of binomial theorem or binomial expansion. So the term which is independent of x in the expansion of this, independent of x, let us take first the tr plus 1 term. You know that it is equal to ncr 6cr, this to the power 6 minus r, this to the power whole to the power r. Now just take the constant term, one side, and x to the power on the other side, because we want the term independent of x. So this power x to the power 12 minus 3r, this 12 minus 3r needs to be 0. Why? Because it will make x to the power 0, this x has power 0, and this is going to give you 1. So it is independent of 1. You will not find x here. So 12 minus 3r equal to 0, r gives you 4. Just place r here and you can find out the value like 5 by 2. So this is the expansion. Example 11, the coefficient of a to the power r minus 1, a to the power r, and a to the power r plus 1. In this expansion, 1 plus a to the power n. These are arithmetic progression. That means twice of a to the power r is going to give you this plus this, right? So the r plus 1 term in this expansion is ncr a to the power r, and also it can be seen that a to the power occurs in the r plus 1 term. So its coefficient is ncr. See, ncr is the coefficient. So the coefficient of AR minus 1, AR and AR plus 1 are NCR minus 1, NCR and NCR plus 1. And since they are in AP, NCR minus 1 means the first and last, if you add, it will give you twice of the middle one, 2 into NCR. And when you expand them, all this will get cancelled, and finally you will get a result like this. N square minus 4R plus 1 plus 4R square minus R. This is what was sought, required. Now you have example 12, show that the coefficient of middle term in the expansion of this is equal to the sum of coefficient of two middle terms in the expansion of this. So 1 plus x to the power n, so they are even number. 2n is even, so on the right side when you expand it, you will get the middle term, one middle term. That is going to give you 2n by n plus 1, this 2n by n plus 1th term, so n plus 1th term. This n plus 1 term is what? 2ncn x to the power n, and the coefficient is 2ncn. Now let us come to this 1 plus x to the power 2n minus 1. Here we have two middle terms because actually it is odd. So we have on the right side, if you expand, you will get two middle values. That is 2n minus 1 by plus 1 by 2, 2n minus 1 plus 1 by 2 plus 1. So you can get 2n minus 1 cn minus 1, 2n minus 1 cn. And if you add them, these two, you will get 2ncn, because we know that ncr minus 1 ncr, if you add these, you will get n plus 1 cr. So this is exactly true. How about finding a coefficient of a to the power 4 in the product? So first 1 plus 2 to the power 2a to the power 4 you expand, then 2 minus a to the power 5 you expand, then you multiply them. But you don't have to multiply each and every term. What you have to find out is you have to find out a to the power 4. So if I multiply 1 with any of these, which of these give me a to the power 4? Only this one, 10a to the power 4. So I will multiply 1 with 10a to the power 4 and write it here. Now let us multiply 8a with some number here so that I can get the final one as a to the power 4. That is, this is the value a to the power 4. So 8a, if it is multiplied by minus 440 then only I can get the a to the power 4. So this term. So that is why I'm multiplying. I'm only keeping those or writing those which gives me the value as a to the power 4, and the rest is this we get automatically, and this is our coefficient of a to the power 4, that is minus 438. Next is find the rth term from the end in the expansion of x plus a to the power n. See, if this is x plus a to the power n, we can say that the first term from the end is the last term. First term from the last term is actually the last term, right? So what there are n plus 1 terms. There are actually n plus 1 terms in x plus a to the power n, because n, so you have, if you expand this, you will get 1 plus 1 terms. So n plus 1th term means n plus 1, and you can write it as n plus 1 minus of 1 minus 1. Similarly, the second term from the end in the nth expansion can be written as, because it will be n. This is n plus 1 term. Previous one is n, then this is n minus 1, like this. So n can be written as n plus 1 minus 2 minus 1. And this n minus 1 can be written as n plus 1 minus 3 minus 1. Okay. So the rth term can be written as n plus 1 minus r minus 1. That is n minus r plus 2. So this n minus r plus 2 term is this one. nc n minus r plus 1, x to the power r minus 1, a to the power r n minus r. Next is find the term independent of x in this expansion. So you just have to find tr plus 1 and keep x on the one side, and the one side you get 18 minus 2r by 3. This is the power of x, and we want it to be 0. This is 0, then only this term is going to be free from x. So 18 minus 2r equal to by 3 equal to 0, that is r will be 9. So this is the term. You have to paste 9 here, 9 here. Next is the sum of the coefficient of first three terms in the expansion of this m being the natural number is 559, and we have to find the term of the expansion containing x cube. So the coefficient of first three terms of this is nothing but MC0, MC1, MC2, and these are the coefficients. You can very well find out. Just add them, you will get 559, and you find out the value, which will give you m as what? M, if you solve this, m will be 12. So tr plus 1 is what? 12cr, x to the power 12 minus r, this to the power r. So we need the term which is containing x cube. So 12 minus 3r is going to give you 3, because it has been told that you want the term containing x cube. So now 12 minus 3r is going to be 3. So r gets 3. Place it here, you will get the required term, that is minus 5940 x cube. Next is, if the coefficient of r minus 5th term and 2r minus 1th term in the expansion are equal, find r. So t, you have to find t, because this is rth term, so tr plus 1, it is t. You can get the r minus 4 term. So this r minus 5th term and 2r minus 1th term of this expansion is nothing but 34 cr minus 6. This is r minus 5 minus 1. That is r minus 6, and this is going to give you 34c 2r minus r. Just equate them. You will get r, and r has two values, minus 4 and 14. We will not take this. This is not possible. R is only 14. So this is your answer. Let us summarize this, that the expansion of binomial of any positive integral n is a plus b to the power n, nc0 a to the power n, nc1 a to the power n minus 1 b till ncn b to the power n. And the coefficient of expansion, we already seen that it is by base Pascal, which we call as Pascal's triangle. The general term of expansion of a plus b to the power n is tr plus 1, which is ncr a to the power n minus r b to the power r. If you have a plus b to the power n is the even, then you get on the right hand side, you get middle term as n by 2 plus 1. If n is odd on the left hand side, the expansion will give you middle term as n plus 1 by 2 nth, and n plus 1 by 2 plus 1 term. So this is what you are going to get. So this is all about the binomial theorem. Thank you so much. Take care of yourself.